See, I think yesterday we saw differences between multi-programming environment, multi-processing environment, and multi-threaded environment. So, in our today's lecture, what we'll try to do is we'll try to see an example of multi-threaded Python program, and we'll try to be more realistic with a real-world example where you can understand the benefit and the use of multi-threading. At the same time, we will understand what are the pitfalls of multi-threading model in Python as compared to other languages like C, C++, and Java. And in case in Python, if you want a true concurrently executing threads, or maybe we can call two concurrently executing Python codes at the same time, then we need to rely on another module, not the threading module. So what we'll try to do is I'll quickly show you how to create a basic thread, and then we will try to model a real world example where threading plays a very vital role in visualizing the uh, in realizing or giving a solution to the real world problem. So, uh, am I audible clearly? Am I audible clearly? I think now it should be better. Okay. So whenever you want to deal with a threading thing, what you need to do is you need to import a module called as threading. So this module is responsible for some of the methods and the classes based on which we will be creating a threads. And as I told you earlier as well, let me open a Jamboard. And, let me use and tell you exactly just a minute. Okay. So for a quick minute, let me also tell you what I am trying to explain. Okay. So we saw it yesterday, right? The additions and all that. So what now will be a little bit specific to Python. So what happens here in case of Python based threading is, remember when you create a Python and for example you have a .py file, right? And it has few codes, code 1, 2, 3, 4. So from line 1 to say line 20. Okay. So when you execute this on a Python runtime, maybe the C Python runtime, which we by default have it when we install Python. So these instructions are executed one by one. Remember, these instructions are executed. The first instruction executed, then whatever the output which is responsible for this that appears on your console. Then the second instruction, then the third, fourth, fifth, sixth, so on to 20 instructions. Right. Now, what I'm saying is I have this 1 to 20. Now, maybe assume that from line number 5 to line number 15, line number 5 to 15, this block of code I want to run in parallel. So, see, when I say simultaneously, let us use the word simultaneous. So, I want to run that in simultaneous fashion. I mean, what I am meaning is, so I want to execute from 1 to 5. So think of this line as an execution line. So 1 to 5. Then at the same time, what I want from 5 to 15, I want this to execute in parallel or simultaneously. It means that so from 15 to 20, like after 15, we have these lines of execution, right? We have this. So instead of executing this thread here, this block of code, this block of code gets executed here. So what do you see here? From 1 to 5 instruction. After that, instruction from 5 to 15 and from 15 to 20, this two set of instructions will execute simultaneously. So who is responsible for executing them simultaneously? The C Python runtime environment and OS below it. So this takes care of that, right? So in case of Python, from 1 to 5 and from 15 to 20, if I want this threads to execute in parallel, right? I want this block of code, which is initially written in a sequential order to in a Python, I need to write it in a specific format. Remember, when we create this threading module, it lets me create a thread. So in Python, what we do is we call it threading dot thread, and we write something. So threading is like nothing but it's an object of class thread. So we have a class thread, we create an object of class thread, and when we ask this object dot start, what it does, it starts this thread, this loop, this thread, it starts this thread. But when I say object dot start and start thread, remember this is something which will execute simultaneously along with the main program's instructions. So when you call object dot start, you need to tell what to execute. You are creating a thread, but the created thread will do what the created thread will do. So you need to tell what that created thread will be doing that. So here in Python, what we do is we give a specific function. Maybe we'll write some function. So let us call run underscore parallel, and I have some instructions here, and I have written this function such that these instructions, when they execute simultaneously along with this instruction from 15 to 20, it doesn't have any dependencies, right? Maybe they are not sharing any shared variable or something, so they are fine to run independently. So what I do is this function, I mention it while defining the thread object. And once I mention this function while defining the thread object, and then when I call object dot start, this creates a thread. And what does it this thread execute? It executes the method which you pointed out while creating this thread object, right? So based on this model, we're going to write our code. Okay, I hope you understood that. Just raise your hand if you understood this discussion. Okay, so going back to that, let us do one thing. What I want is let us print some numbers, right? We will write few methods here which will print the numbers. So what I'll do is for I in range, I'll say 0 to 10, and I'll print those numbers here. Right. Okay. At the same time, for I in range, I'll say from 11 to 20, print I. And what I'll do here is I'll add some text to this. And here I'll append this a dollar, right? So now if you execute this code, and in the end what I'll do is I'll say print end, right? So I have written this block of code, and now if I run this, okay, what output you see this? So initially you have hash, so you can see that first this for loop executes and then the next for loop executes. Now what I want is I want to, let me see if I can dock it to, okay, so I think this way the output you can visualize well. Okay, you can see the output is in a sequential order. But what I want here is I want to execute this both for loops simultaneously, right? So let us execute this block, line number 6 and 7, as a threaded one. So as you all know that if I want to create a thread object, How do I create a thread object? So let us call it as T is equal to threading dot thread, and here this creates the thread object. What I am doing here, I am creating a thread object, right? Now to start the thread, what I need to do, I need to call t dot start. So this will start the thread. Right now, if I execute this, it creates a thread and it starts, and I further continue with this next line of instruction. But now whatever the thread which you're starting, what it will do upon starting, it has nothing to do, right? So if I want to tell what this thread has to do, what this thread has to execute when I ask it to start, you need to mention a method. So here we are planning to get this block of code to execute simultaneously along with this block of code, right? So what we will do is we will now write this block of code in a special method def. So run simultaneously, and here is where you put this, right? I hope you're getting this. So this block I placed it in, and here when I write it, so I have a keyword based argument, and I need to say target is equal to run simultaneously. That's it. So what I have done, I have created a thread object, and I said when this thread gets started, it has to execute this method, and whatever code you write in this method, that would execute in parallel with this main. Remember, you have this demo.py. So when you execute this demo.py, the demo.py itself executes as a main thread. So when you run this program, the program itself is a main thread under the Python process. So this main thread, along with this main thread, which is executing the code inside demo.py, along with that, the moment it encounters this line number 7, 8, and 9, the 6, 7, 8, 9, it creates another thread, and that thread will execute instructions 2, 3, 4, whatever you mentioned in this instructions here. That will execute simultaneously along with the main thread, right? So now, and typically what I want, initially I want to start this before this method. Okay, so now I'll tell you how this executes. So this executes import module. This is a function definition, so nothing to execute, it's just a function definition. So for loop starts, right? A for loop starts 6 and 7, it prints everything, and after starting the for loop, you are creating a thread, right? So if you execute 6 and this block, what happens? It will print numbers from 0 to 10, and but what I want is, at same time I want even this block of code to also execute. So now if I execute this, let us look at the output. Then you will understand what is something I need to take care when I'm writing a thread based program. So let me run this program. So now when I run this program, right? Remember, let me run it again. Okay, what do you see here? Initially you are seeing all hash base this. It means that the block 6 and 7 is executed. After that, what you see here? You see here end, right? You see after that, okay, so after that, this block has started executing. T is equal to threading dot thread, and you call thread dot start. So it created a thread, and that thread started simultaneously running along with the main thread. So the thread started, it started printing from 11, 12. But why did you get this mixed output here? Because this block has started in in parallel. Let us call it as in parallel to this main thread. So still main thread was free to continue its path. So it has started the thread, and main thread had some instruction to execute. Then it's printed it end, and after calling end, main thread finished its execution, but still I had this thread running. So it started printing its number till 19, and then the entire process finished. But what if I want now? Tell me in a comment window, whatever the see, I have created a thread, I have started a thread, I have written that, but tell me, am I getting a simultaneous execution? What I wanted, I technically wanted this loop code and this loop code to run simultaneously. Tell me, are they running simultaneously? I have created a thread, I have done it, but are they running simultaneously based on this output? Can you tell me? Put it in the chat window, yes or no. Yeah, so yes. So what you told her, yes, they are not running in simultaneously. Why? I have used the thread, but still they are not, because of improper way of writing my logic when I want to execute threads in parallel. So what I need to do is, can you tell me what I need to do is? So either you start this first, start this thread first, and get it exit. So it starts, then control comes back. In meantime, it starts running that, and you also get this running. So now, if you execute this code, okay, what do you see the output? So you see 11, 12, 11, well, some hashes and some dollars. So every time I run this, you will find some different output, because maybe someone takes a chance and another runs it differently. If you want this to be more visually, what I can do is I can give a sleep timer. So I can say it's in milliseconds. So I need to import a module called as time, and it lets me do sleep. So after every for loop execution, I'm giving a small time delay to visualize the difference. I think it is in seconds. So let me give zero point 0.5 seconds. The unit is in seconds. So now if you execute, okay, do you see this simultaneously? You see different outputs. You won't find any sequence. You run it again, you will find some different and entirely different sequence. Okay. So understood how to create a thread, and just defining thread itself is not enough. You need to properly place it at an appropriate location. You need to trace appropriate flow so that you will force this block of code to execute simultaneously. Okay. Tell me, have you understood this? Raise your hand if you have understood this. Okay. So as you have said yesterday that threading was already introduced in the Java course, can you tell me the major difference between the way threads execute in okay, forget about how they execute internally. Can you tell me what is syntactic difference? What is syntactic difference? See, I'll tell you. In case of Java, you have a restriction of writing your code inside public void run. When you create a class thread, when you extend a class thread, whatever code which you want to execute in simultaneous fashion, that you were supposed to only write it within public void run. But here it is not that restriction. You can write it at any function. You can write it at any function. Just provide that function as a input to this target keyword argument, right? So if you want to pass some arguments, let us suppose you want to pass some arguments. So here I want to pass the I, maybe the start value. So here I'll say start value, right? So if I pass start value and if I pass target, how do I pass the arguments? The arguments to this method are passed here as a tuple. So this value which you mentioned here, that gets automatically passed to run simultaneous. So now if you execute, you should see these values instead of 11, you should see them with 200. From 200, okay. So let us also call end underscore value. So from range end underscore value, so 200 and let us say 220. Right. If you execute this, do you see this? So these arguments have been passed to this method. So this becomes a bit tricky in Java. In case of Java, you are not allowed to pass any argument to public void run. But here in Python, you can do that. Understood? Have you understood this? Like the flexibility in Python which you get while creating this threaded objects. Okay. So see, we have seen some theoretical example, right? So we have seen a very theoretical example. What I want is I want you to visualize some real world example. So let us suppose I want to write a program. Let's say, so I want to take a number from a user and print square value of it, right? So how do I say that? Print a very simple program I want to do. Enter a number, enter a number to calculate the square value, right? So you get this message. So then you will say number is equal to, how do you take input? That's how you take an input. I think you can also write this prompt within that. So when a user enters the input, what you will print is print the square of your entered number is so number into number. Fine. Here. So let us run this program. Uh, let us go to run and run. So you can see here, it is asking me to enter a number. If I enter two, okay. So can you guess what's wrong? Is input always takes them as an integer. Okay, convert it to integer and run. So now you entered 2 here. The square of number you entered is 4, right? It's calculating, right? Now you might ask me like, what is where is threading into this? Let us look at the threading example. Now let me run this again, and it is asking me to enter a number. Now think of a use case. It is asking me to enter a number. Assume that my keyboard is now not working. Think of this case. My keyboard is not working. I'm not able to enter any input here. What will happen to this program? Can you tell me what will happen to this program if I do not enter any number to this prompt? So till now, I think in your C language, C++, Java, you might have written hundreds of such programs where you ask user to enter input, and fortunately, every time the user was able to enter an input. But what if user is not able to enter input? So this is the most realistic use case world. How many of you go to ATM and withdraw cash? So when you go to ATM and when you withdraw cash, when you swipe your ATM card, it asks you to enter your PIN number. What if you do not enter the PIN number? Will ATM get blocked? You have inserted a swipe. It has asked the PIN number. You didn't enter a PIN number. What will happen to ATM? Will it wait forever to? Yes. So what it does? What happens? What happens with that? It timeouts. That's a real world problem. This is what we call it as real world applications of your programming concepts. So tell me, you will never ever find any program which asks end user to input to indefinitely wait for an input. It times out after a specific amount of time, right? So I hope you understood the use case. So here what I want my program to time out. So I am asking to enter a number. I want my program to time out if user doesn't enter any input within 5 seconds. If user enters the input within 5 seconds, I need to calculate a square, I need to print, see your output is so and so. If it doesn't enter within 5 seconds, you have to display a message timed out, right? Tell me now how I can get this realized. So here you need uh, another set of procedure or a Python subroutine which will run simultaneously along with this main thread which is waiting for the input. So that thread will wait in background for 5 seconds, and if it doesn't find any input, then it will just time out. It will kill everything and it will just time out. Understood this? So can you think of a logic and a flow to have that program? So let us write that program, and you will understand how threading is useful. Right. So I've entered a number to calculate square value, and this is all there. So what I want, I'll take one boolean flag entered input is equal to. So I will set this value initially to false. This is a boolean value. I think I did not write. Entered input is equal to false. And I'll define a method which will execute in parallel, check for timeout. So what it will do, so what initially it will do is it will wait for 5 seconds. It will wait for 5 seconds. After 5 seconds, it will check if entered input equal to true. If it is true, what it does, it just uh, okay, it just exits. Here I'll write 0. Else what it does, else it prints a message timeout, try running again. After that, I want to get this exit. So two ways to exit. This threads exit in two ways. Either first by asking, checking entered input is equal to true. If it is, it doesn't message anything, it just exits. And remember, when does this execute? It executes after the thread starts and waits for 5 seconds. And within this 5 seconds, I'm ideally expecting the user will enter the input, right? So exit and exit. Give me a just a minute. Okay. So print a number to calculate. Okay. So after that, I need to create a thread. So T is equal to, how do I create a threading dot? Give me a minute, just a minute. So so t is equal to threading dot thread. I need to define the target. Target is equal to check for timeout. We misspelled check for underscore timeout. Then after that, I need to start this. So t dot start. Okay. So now this is a block to create the thread. Now tell me, where should I execute this thread? So start this thread and wait for input, or ask for input and then start the thread. What do you think? Two options. Okay. So option one I'm giving you is, first start thread and ask for input, or option two, ask for input and start the thread. What is the right way for me to structure this? Can you reply? Start thread and then ask for user input, or ask for input and then start the thread? Okay. So if I go on this option number two, what you're asking me is, this block of this code will come after this. Is it right? Is this right? So my question was, I think you're slightly misread that. My question was, will this block will come here or will it come here? 1314, will this block come at this 1314, or after this? See, if you put it here, I'll tell you a problem. This is blocking call. You won't come to line number 16 unless user enters the input. So the whole purpose of displaying a timeout message doesn't make any sense. So your call waits at this line. So this thread 16 and 18 will not, this line, these lines will not start at all. So no question of any background process waiting and checking for timeout after 5 seconds. So this has to come, ask the user for input, start the thread, and then call number is equal to input. You will display the prompt, then immediately you will start the thread. So you have started the timer. Think of this thread as a timer for waiting for 5 seconds. After waiting for 5 seconds, so the moment this starts waiting for 5 seconds in background, at the same time, once the thread is created, control comes back to main thread and this line executes. So at this line 13, 14, 15, when these lines execute, 13, 14, a background process waits. 15 thread, it's a main thread, it waits for a user input. If user doesn't enter anything for a 5 seconds, then the in background threads code executes and it displays the timeout method. And here, if user enters the input within 5 seconds, if user enters the input, and if you reach to line number 16, if you are coming to line number 16, what is its indication of? It is indication that user has entered the input. If user has entered the input, what you will check? Entered input is equal to true. If you come to this one, if user enters the input, print the square of your enter number is this, and then print, and in the end, I think here you can exit the program. Are you getting this? So let us execute and see. Let us execute and see. So method, this waits for 5 seconds. It checks if input is equal to 2. Let us think of a use case where you entered this message. Thread is waiting for one. You have asked for an input, and user has entered the input immediately. So entered input is equal to true. It calculates the square and it prints it. So in backend, after 5 seconds, when it executes this line, entered input will be true and it exits without displaying any prompt. If user doesn't enter input, this line will not execute and entered input will always remain false. So you will never enter the if, you will enter into else and you will print a timeout, try running again message. Fine. So, okay. Quickly raise your hand if you have understood this flow before running our program. Okay. So let us run and let us see if it executes as per the expectations. So the first thing what we will try to do is we will not enter an input. Okay, maybe we will enter an input. Okay. So what has then? So enter a number. I entered a 2, but I did not get any output. So timeout, try running again. Let me see what's the problem here. Let me run again. Uh-huh. Number is equal to entered input is equal to. I think it's something is waiting in background. So it should have. It isn't taking that. Let me see. Did we give a 5 second sleep in thread? So sleep is time dot sleep 5. Uh, enter this. Okay. Can you tell me what wrong we have done that? Can you guess? Where is my what is going wrong at what point it is going wrong? Check the code. Something we since we relied on IDE too much, we encountered this bug. We'll not call it as error. It's a bug. Bug means your program doesn't function as expected. So what is wrong? Identify the wrong where we have done something wrong because we relied on IDE to do auto completion for us. What is that line? It's line number 14. See, look at line number 14. Here I have included the rounded bracket. Rounded bracket means it's a call to function. I don't want to call function. I need to just name the function here. That's it. This is very important. And it all and very frequently this happens because we rely on IDE to complete. So it thinks of this in function call. I hope you understood why it is that. So every time I do that, I'm actually calling the function, it is checking and it is exiting that, right? So we modified that. We removed the rounded brackets here. Now let me run this again. Okay, so if I enter 2 here, the square of number is 4 and process is executed. And if I run again and I do not enter any input, now I'll not enter any input. So I should see a timeout message. Okay, so it displays timeout, try running again. So have you understood this? Let me know if you have understood the flow. But if you still look into this, 2, I get this number and it exits. If I do not enter any input after 5 seconds, it says timeout, try running again. But it is still waiting. If you look at this icon, the program is still waiting. I want the program to clearly exit. So the issue is that, so it is still waiting for a number. It is still waiting for a number. Only my thread executed. So this exit here technically did not exit the process. What it did, it exited the thread itself. So exit call here, it only exited the thread, but the main thread is still waiting for me to calculate the input. So I don't want process to wait. So what I need to do is I need to see if I can use system.exit. I think it should be sys.exit. So when I say sys dot exit, it should exit, but I think this will this might throw some exception, because from background threads it is not good to kill the main process. So wait, let us wait for timeout. Okay, even after doing it, is not, it's not killing that thread. Sys dot exit is also not killing that thread. We need to figure out a proper code which can kill the main thread from the background thread itself. So, but our logic is working fine, but it has to kill this process. It isn't killing that. So sys.exit is not working. Let me see. Can you suggest anything? Can you suggest any code which kills the main process? Let me search and see if I can get this. Okay, it is os.exit. It is os.exit. I think there is another module, import os. So instead of calling sys.exit, I'll use os.exit. So if I enter a number, yes, process finished. It calculates the square. And if I do not enter an input, after 5 seconds, process finished with exit code, but I think still it didn't. I think still, okay, yeah, it finished. You can see that it finished. It is now no longer waiting for any input. I hope you see this here. Okay, so understood. Okay, yeah, I think Anuj has used if else to exit. See, I think if else will not make any difference, because the problem what we were having is, when a thread is calling exit, see, the exit has lot of meaning. Just call exit, it is killing it itself. If I call sys.exit, it is killing the Python process. It is attempting to kill the Python process, but it isn't able to do that. So an actual technical way to do that is to call os.exit 0. It kills it from the main thread. So now you can see that it's killing that. Okay, so you can see here, run demo. See, if it is red, means process is still running. So wait for 5 seconds. It is done. It killed it. So os.exit 0 is I won't say the right way, but a dirty way to kill that, because we are entering into a domain called as race conditions, deadlocks, and multi-process communications and all that. So it is not good to kill the main thread directly from the background. So there are a lot of issues. I think you will learn those concepts in operating system. For us, we just wanted a solution to os.exit and kill this one. Okay. So I hope you understood what exactly the threading is used for. Now remember, this program, we couldn't have written this program for this use case to time out the input without using a module which supports us to write block of codes which can execute simultaneously and or concurrently. So raise your hand if you understood this. Now have you understood the real purpose of threading? Instead of just writing some fancy for loops, simultaneous prints, this is something which perfectly visualizes you the use of multi-threading in Python. Okay, and also let me give you a very quick overview. I'll tell you what are possible pitfalls of multi-threading in Python. Not much, just a small thing. Okay, so I'll tell you what is difference in Python based threading and Java based threading. See, yesterday what we said is on a platform I might have multiple cores, core C1, C2, and C3. If my machine is a quad core machine, think of this. So in Python, so when I create a simultaneous program by using threading module, so I have this Python process, right? Under this, I might have multiple threads, and then I might have this main thread. So in threading Python, when you create this blocks which execute simultaneously with the help of threading, they all execute on one single core, only on one single core. Even if you have a 4 cores, in Python, when you execute this .py file, they always execute on a single core. So technically, what kind of parallelism you're getting? You're getting simultaneous execution of threads. But remember, if you have a quad core and you really want them to run in parallel or concurrently, yesterday we saw what do we mean by concurrently executing that. So if you want some block of codes to concurrently execute and utilize multiple cores, we do not use threading module. What we use another module called as multiprocessing. What I call it as multiprocessing. So the syntax is almost similar, the same semantics as well. But in that case, when I execute this thread and when I create a thread like parallelly executing blocks, there what they do, this could run on this code, and this another simultaneous block of code, same time block of code, this could run on two different codes. So here when you execute them with the help of multiprocessing module in Python, this is where you get a true parallelism. What we call it as, they are truly executing in parallel, truly executing in parallel. This is simultaneous. But see, this both are better than a sequential block of code. Both are better than sequential block of code. And remember, we cannot always want to write a multiprocessing. Why we rely with a thread? See, the difference between these two is obviously this will give you a greater degree of parallelism. But here, all these threads, they share a common copy of memory. Here they might have a different copy of memory, different semantics, and that. So this parallel execution, the backend stack which helps you execute this will be an heavy one. So that's why threads are also called as lightweight processes. What threads are called as? Threads are also called as lightweight. These are called as heavyweight because each of this same parallelly executing block of codes have their own set of some. I think if you are studying operating system, you'll understand PCB, process control blocks, program counters. You have state program state. So each of this will have its own such thing. So this becomes a heavy, and this becomes a lightweight. I hope you understood. So in next lecture, we will try to convert the same program which we executed with the help of threading into Python multiprocessing environment. Or else I can share you a proper link to a tutorial where you can try to do this on your own. Okay. So would you like to give it a try? Try to learning multiprocessing. Okay. So Anuj has asked which is more efficient. So it depends upon various cases, but in terms of parallelism, in terms of speed, in terms of utilizing CPU in a better fashion, multiprocessing will be efficient than threading. But remember, when you go for multiprocessing, there are a lot of additional complexities. There is nothing in between these two. Memory wise, multiprocessing will occupy more memory, threading will occupy less memory. Okay. So this was the glimpse of multi-threaded programming in Python.